This is the latest incarnation of the motherboard, or backplane, whichever you prefer to call it. And it has the power supply connector on it to use a PC power supply. But the card looks pretty good. There it is with the edge connectors in it. All the parts, on-off switch. Also a couple of empty holes there where you can put an external on-off switch on. The on-off switch turns the computer supply on and off via its power connection. And as soon as we get that 7905, no reason that shouldn't work fine in there. That's a circuit I've used a lot of times. So I'm sorry, 7909. I always think of 5 volts. It's minus 9 volts, so I'm waiting for the 7909. And here's the bare board, the way it comes from the Chinaman. It's where your connector goes, right there. So one error on this board, when I was messing with it, I missed the trace lines that connect this 8-bit data port right here. But I don't use that anyway, so that's no bother. I doubt if I'll have the boards remade just for that. And here is the combination ROM and RAM memory board. EEPROM will go right here, and the 61256 right here. So that's 4 boards worth of the original 1101s, and much less power. Much less power. These are low power devices. 32K bytes memory here for less power than one of the 1K boards before. So that's going to be pretty nice. I've got that working. I'll show you that in a minute. It'll read and write on the EEPROM and the RAM, and the selection seems to be working okay. However, there's a minor problem with the write logic to write the RAM, which is really no problem in practical application, because I program those EEPROMs with a Arduino anyway before I put them in. But I also do want to be able to write on them there, so I'll correct that. Next version of the board, I'll fix that. And there's only a 1-line difference. Have to pull up one connection here, scratch it off, and run a jumper from this IC over to this one. And I think the write logic will work okay too. We don't really want to do much writing on that EEPROM when this thing isn't being used in the computer, but it's nice to have the option to do that. And you could use the switches on the front panel, or the Arduino panel replacement, control panel replacement, to drive them one by one. Okay, that's where we're at, and it seems to be hanging together pretty good here with this version. So we'll do a little more playing with it, experimenting with it, and we'll see how that comes out. I'll show you the EEPROM program setup that I've got with my Arduino Mega. Here's a new version of the memory board with all the parts stuffed in it, and it's running in the computer. I got it set up for 256 bytes of the EEPROM right here. That's the AT28C 256 32K ROM chip. They only cost a couple bucks, but I'm only using 256 bytes of that in the lower part of the memory right now. And the rest, I select it with these switches down here, plug switches, or jumper switches. And this is the 61256 UT, or UM61256. That's the RAM memory. And that's working pretty well. Like I said, I can't write on it, the EEPROM in there, but that doesn't bother me because I program it with a couple of programs that I put out on the FTP site. And the information to get to those I'll put in the comments down here. But that will on YouTube, the YouTube comments, and that'll take care with the Arduino Mega program, the little sucker. So what I did on the test bed here was move the slots around and put the readout LED readout board where the memory board really should go. Since they're on the same bus, that works fine. So you can see it running back there. That board normally would be in the front of the computer. That's how you monitor it, but it's easier for testing to change their positions around. Then I can pull that board in and out of there with less trouble than if it was back there in the stack. Okay, on to the EEPROM programming part. This is the EEPROM programming setup. It uses Arduino Mega, mostly because it's got so many output pins I don't have to mess around with shift registers in order to get out all 40 of the pins on the EEPROMs. EEPROM, by the way, stands for Electrically Erasable Permanent Read-Only Memory. So that's what EEPROM stands for. And there we are. We have about 20 of them here. 2 of these were no good. I wrote a little program to test them. These came from China. These 2 are no good. But I keep them in here just in case I have a program error. Maybe there's something I don't know about them. And these, the 8K versions of that chip, the AT28C64 is all of these are bad, all 10 of them. And I got checking around on the internet and I found out that there are other guys who've gotten some really bad ones from China too. So I ordered another batch of both of these and the C16, which is the 2K version, from American suppliers, the manufacturers, in fact, Atmo. And let's see. This is a 40-pin ZIF, zero insertion force socket, so I can put these chips in and out with no problem, and then check them by just hitting the reset button. And over here is the same setup, except I'm just using the breadboard here to plug in the RAM chips, 61256. Works out that the pin out of the 61256 is the same, pretty much the same as it is with these chips, so I use that to check the 61256 RAMs also. But that's, I could check that over here if I had a different socket. This is for a wide, you can see if these are wider space than that narrow 61256 and the pin spacing. These programs to run this, the Arduino programs, are on my FTP site, ftp://arjugo.asus.com, and that's where you can download them. They're in the 8008 directory, 8008. Okay. Oh, the Kicad, however they pronounce that. I've heard it both ways. CAD files are also out there on the directory under Kicad, the Kicad directory. All right. Any questions? Give me a shout.